Hello, good evening, and welcome to this third and last RobotStudio tutorial. In this video, I will show you the program I created. I will show you how a conveyor belt is controlled and used to complement a process or a system. I will start by showing you the robot. All right, so in my station, what I did was I added a robot. It was placed on a pedestal or a base, only so it could reach or more easily reach the conveyor belt. As you can see, the conveyor belt has a tray and a can on it. What this does is it moves the tray and the can towards the robot. The robot moves to or near the pickup position. It waits for the can to be in position, only to pick it up, close the gripper, and move it to the box, which is this one here. It leaves the can there and it moves back to its home position. Additionally, you may see a fence and a mat here. Those were added for safety purposes. First, I added this fence or this wall is intended to keep humans away from the operational area of the robot or where the robot works, just in case, so it doesn't accidentally hurt a human. What I did was I made sure that the entire and the whole robot was inside it, as well as all of its working area. Just for two reasons. The first one, so humans don't get near it, and the second one, just so the robot doesn't hit the fence. You may also see this red mat. The purpose of the mat is to indicate that this area is not to be stepped into. You may have seen, I chose the red color because first, this color indicates danger, and it's also used on by drivers to indicate that a car cannot be parked on a place, maybe because of different reasons. Could be because of it might be a fireman station, or simply because it's an exit, an emergency exit. So that's why I chose the red color. And here you may find a pedestal, another pedestal, and a flex pendant. The whole purpose of this safety measurements are to keep humans away, and so they don't get hit or hurt by the robot and any of the tools or any object it interacts with. The flex pendant was placed outside of the working area of the robot, so it can be controlled without being in the work area, and for maintenance purposes, or in case a human has to enter the fence, I added a door here. Okay, now regarding the program, just as we did on the last tutorial, once we had added all the necessary things like the box, the robot, and the conveyor belt itself, what we did was we taught the robot the positions or the targets where it had to move. This was done by moving the robot to the position and only clicking teach target. The targets that I'm going to show you, they were divided depending on the work object they were placed on. This is for to make it easier. In this case, for example, the home position is taught using the word. Why is this? Because in theory, the robot will not be moved. The second work object I added was the box. It's placed on the box, and this is used to select or to show the robot the drop position and the point near the drop position. These two targets were thought on this work object because if you move the box, then all these targets are going to move with the box. And for the same reasons, the pickup position and the point above the pickup position were thought using a work object that's set on the conveyor belt. If you move the conveyor belt, then all this pickup position and the point above the pickup position will be will move with it. The other important thing we need are the signals. Here we used 4 signals, 2 input signals. Both of these are used to indicate something. The first one, called conveyor inside, DI stands for digital input, conveyor is inside. This is used to indicate that the tray is already inside or in the position closest to the robot. We have the digital input, gripper closed. This is used to indicate that the gripper is closed, as you may have guessed from the name. And the first digital output I'm going to talk about is the gripper, closed gripper. This signal is used to indicate that the gripper has to close. And this digital output is used to indicate that the conveyor has to move the tray and the object to the position near the robot. Then in rapid, we are going to see here the program I used to control the movement of the robot. The first thing you're going to see are the targets that were defined previously. Then what you're going to find is the movements that the robot is going to perform. Since we don't know where the robot is going to be previously or before executing the program, we require it to move to the robot to the home position. This can be done using a joint movement, and it doesn't have to be slow nor precise because it's not going to be interacting with anything. Then we move near the pickup position, not precisely to the pickup position, this will be done later, because first we need to get the can to the position where it's going to pick it up at. This is done by activating the digital, this is done by activating the digital output, and it waits for the signal to be activated, the indicator that the can is already in position, and only then it moves to the pickup position. This is done slowly and with fine movement to make sure that it reaches the object, and it closes the gripper. This is done by activating the digital output and then waiting for the gripper to be fully closed. Once it has grabbed the can, it moves away from this pickup position to the home position and near the drop position. All these 3 movements can be done fast because it's not going to be near anything that it can hit. The first movement is a linear movement because it's in a point near where it picked it up. And the 2 following movements are joint movements. These 2 are long trajectories, so it's not a good idea to move it this way, or it's not a good idea to move it on a linear way for those 2 cases. Then, since it's already near the drop position, what it's going to do, it's going to move on a linear way to the drop position, and slowly and with a fine movement, because now it's going to be interacting with another object. And then it lets go. It lets the can go by opening the gripper and waiting for the gripper to be fully opened. This is done by deactivating the closed gripper signal. And then it finally moves away from the drop position and to the home position. Now I'm going to show you how this simulation works. I'm going to move closer to the robot so you can see it. And I'm going to click play. As I mentioned, the can starts moving towards the robot. When it's in position, the robot picks it up, moves it to the box, and the robot moves back to its home position. And I hope you like it. Thank you.